There, we are doing a quick review of two variable systems. This is a skill you were taught in Algebra 1 and reviewed quite a bit in geometry, but we are reviewing it so that you do have a foundation for when we get into three variable systems next. So, substitution and elimination are the two ways by hand that we solve two variable systems. Remember, a system means more than one equation. So when we have two variables, in order to solve it, we need to have at least two equations. So substitution means I get one of my variables alone and I substitute it into the other equation. So looking at my second equation here, this one is going to be easier to get either x or y alone because the coefficient is 1. If I were to get x or y alone in the top equation, I would have to do some division and get some not pretty numbers. So on this first equation, I just want to get x by itself. So I'm going to move the 4 and the y over so that it's y minus 4 equals x. So now I'm going to substitute this expression into x in my upper equation. So that's going to be 21 times 4 minus y equals 6y plus 30. Now I just have one variable and I'm solving using my Algebra 1 skills. 21 times 4 is 84 minus 21y. Now I want to get all my y's on the same side, get all my constants on the same side. So 54 is equal to 27y. When I divide by 27, I find that y is 2. Okay, I found y. Now I need to find x. And so I can just plug this back into any of these equations. This one's going to be easiest, though, because it's already set up to solve for x. So just 4 minus 2 is going to be 2. So x and y are both 2, and I give my answer as an ordered pair, 2, 2, inside parentheses. Substitution. Elimination is another method, and for this one, we either get our x's or our y's to cancel. So let's look at our two equations. I need to have all my x's and y's on one side and all my constants on the other, which this one already is set up that way. So I have 9x and x, and I have y and 2y. Well, if I multiply this top equation by negative 2, meaning I have to do all three parts by negative 2, I'm going to get negative 2y, which will cancel with my other 2y. So when I add this together, sorry about that bell. So when I add those two together, I'm going to get negative 17x, that cancels, equals 16 plus 18, which is 34, divide by negative 17, and I get that x is negative 2. Once again, I need to plug that negative 2 into one of my equations to find y. So I'm just going to do the second equation because it's smaller numbers, so I'm less likely to make a mistake. So negative 2 plus 2y equals 16. I'm just solving for y. 2y equals 18, which means y is 9. And that answer is an ordered pair, negative 2, 9. So those are the two ways we solve by hand. The third method is graphing. So you're going to need your graphing calculator at this point, so go ahead and grab it if you don't currently have it handy. Okay, I'm going to label these equation 1 and equation 2. So let's graph them by hand first. These are both in slope-intercept form. So for my first equation, I know my y-intercept is negative 1, and my slope is also negative 1. So I am going to draw that line with a slope of negative 1. Okay, so there's equation 1. Now equation 2, my slope is positive, my intercept is positive 2, and my slope is negative 1/4. And then I'm going to connect those dots. Now, I can clearly see on this graph where they intercept each other, and that is at negative 4, 3. So that is my answer, my ordered pair, my solution. Now, some of these are harder to graph by hand, and if you're not super neat and careful with it, you can make a mistake and not find the correct answer. So I'm going to show you how to do it in your calculator. So you're going to go to your y equals menu, and you're going to put your two equations. So the first one goes in y1, negative x minus 1. And then in y2, I'm going to put the second equation, negative 1/4 x plus 2. Now I'm going to hit graph, And if you need to adjust your window, you can either hit window and adjust your X's and Y's, or you can just zoom in and out. But I can see right here, this is where they intersect. So I can tell the calculator to identify that point for me by going second, calc, and then option 5, intersection. Now you use your left and right arrows to just arrow over the blinking black cursor. You're going to get it as close to that intersection as you can, and then you hit enter 3 times. 1, 2, 3. And it will tell you the intersection is at -4, 3. So that's how you do it in your calculator. So let's talk about some special cases. For these two equations, I think elimination is going to be an easier option. So if I multiply one of these by -1, I'm going to get -6 equals positive 5x positive 6y. And if I add those together, everything is canceling. So I end up with 0 is equal to 0. This is a true mathematical statement. So this answer would be all real solutions, all real numbers, infinite solutions, however you want to phrase it. But when you end up with a true mathematical statement like 0 equals 0 or a number equals itself, then that is infinite solutions. Now this scenario, I can go ahead and use elimination because my x's will go ahead and cancel, but I want to get all my variables on the same side, so I'm going to move that 5y over first. And then I'm going to go ahead and combine my equations, and then my variables are canceling, and now I have that 0 is equal to 85. This is a false mathematical statement, so my answer is no solution. So a true statement is infinite solutions, a false statement is no solution. Now, hopefully this is sufficient review for you to get comfortable with 2 variable systems again, so that next time when we start 3 variable systems, you can pick it up quickly.